We're going to look at an example of graphing a reciprocal function. In this case, we're going to graph a parabola and its reciprocal. So a question might say something along the lines of graph the function f of x, and then the part B would be graph its reciprocal, or 1 over x. So first of all, we're going to have to function. So in this case, we've got our quadratic, fortunately, well, kind of quite kindly in the intercept form, right? We're written in a form where if you just use the null factor law, you can see pretty quickly that your intercepts are going to be at 4 and at -2, here and here. And then probably what I'd do before I actually draw it is I'd think about, well, where's its turning point going to be? If I think about it, the turning point's got to be halfway between those two intercepts. We know that our parabolas are symmetric. So if you think about it, between -2 and 4, that's 6 units between them, right? So halfway between would be 3 units. So we just go 3 units from either one towards the center. So it would be 1 would be the x value, right? If I then, so x value of my turning point would be 1. If I sub that in, so f of 1 would be, well, 1 take 4 is what, -3, and 1 plus 2 is 3, so I get -9 as my turning point y value. So I'm down here at 1 -9. And now I can graph it. I'll just zoom out a little to make that a bit easier to graph. And you get something that looks like that, right? Try to make yours neater than mine. Hopefully I don't have to do tests. Now, so we've graphed the function. Great. Here is f of x. We could even label it. Now, and we've put in all the key features, right? Now we want to graph its reciprocal. So what I'm going to do is a couple of things. First of all, I think about, all right, well, I know my reciprocal functions, everywhere that my original function has an x-intercept, I'm going to have asymptotes. I'm going to put them in. So I get one asymptote here at x equals -2 and one at x equals 4. So I've put them in, I've labeled them. Now what I've got to do is I'd probably think about, if I think about the big values of x, so say when I go out here, right, where x gets bigger than 4, the parabola very quickly gets really, really large, right? The y values get really, really large. So their reciprocals will be really small. You're dividing by things like, 1 divided by 1,000, 1 divided by 1,000,000, 1 divided by lots, right? So when we do that, we'd end up with something that's approximately 0. In other words, you're getting an asymptote out this way, right? And same when you're going towards the negative way, when we go this way, we're also very quickly up here getting really big positive numbers. So we're doing 1 divided by a big positive number, that's basically 0, right? So we're just drawing this asymptote, y equals 0 is its rule. And so what we can do is, now we've got all our asymptotes, we could do the kind of outside bits, as in the bits not near the middle. So we said that out here, it's going to be basically, I might change color again. Here we go, let's just go black. So out here, it's going to be hugging that asymptote. So try not to have your graph cross your asymptote. And then if we think about it, as we get towards that intercept, our y values are getting smaller, really small in fact. So this is going to asymptote up that way towards the other asymptote. And then we just get something over here that looks really similar. It might help you to remember that thing is with our reciprocals, right? If you put into your reciprocal a positive number, you get out a positive number. Likewise, if you put in a negative number, you get out a negative number. So your reciprocal graph here in black, one on f of x, is always going to be on the same side of the axis as your normal function f of x in red. The last bit we got to do is the bit in the middle, the kind of weirder looking bit, maybe. I mean, the other bits look pretty weird anyway, but even weirder. So one thing to remember, wherever our original function has a maximum, our reciprocal has a minimum, and vice versa. So here we've got a minimum, so our other function must have a maximum, our reciprocal must have a maximum. So f of x has a value of -9 at its minimum. So the maximum of the other one must be 1 over that, which is 1 over -9, so it's minus a ninth. So a very small number. We can just draw it in here. This is not quite to scale, really. It's too big, but we'll just put in and label it, and our examiner can deal with it. So it'd be at 1 minus 1 on 9, yeah? And then we just have to kind of have it hug the asymptotes, right, from there. So it's going to go out like this, and over here, it should be symmetric, really, because your parabola is symmetric. So we might just get rid of this yucky looking bit. And that's really all we have to do. We don't have to worry about intercepts here. It doesn't hit the axes. So, oh, actually it does there. Well, you know how to work out intercepts. I'll leave that to your very capable selves. And that's it.